Hello everyone, welcome back to our 5th episode of Kima Labs podcast. Today we are in the heart of the Flex Power Grid Laboratory here in Arnhem, where we perform a series of testing services which are supporting utilities and manufacturers to test the equipment before they get in operations with a cutting-edge setup, with a new approach called hardware-in-the-loop testing, which is the approach we are going to deep dive today with Renzo Fabian, the head of the lab, that will tell us how this testing method that is going beyond the traditional testing lab methods is supporting our clients to get deeper into potential issues before their equipment gets in operations. So thank you very much, Renzo, for welcoming us in your lab. So I wanted to start with the first question of today. So how does hardware-in-the-loop testing supports manufacturers to validate their equipment before they get in operations? Why it is an effective risk mitigation tool, also in light of what we have recently seen in large-scale outages that power systems have experienced. So can you tell us a little bit more about this method?
Thank you, Antonio, for coming. Yes, this lab is a Flex Power Grid lab here in Kema in Arnhem in the Netherlands. This is a medium voltage lab. As you can see, we can test here devices until 30 kilovolts, and our power is related to 1 MVA.
Wow.
Yes. And also we provide this cutting edge technology, as you mentioned, that is not that new, but there are not much laboratories that can provide this kind of tests at this power of level.
Great.
Yeah. We work in different areas related to hardware in the loop. Hardware in the loop means we are able to put real hardware, a real device in the loop. That in one part of the loop we have a digital simulation, and then we interact with a real device. You mentioned large blackouts. This year we had one in Europe, one in South America, and at least is not the total reason, or actually it's multifactorial. But at least misoperation or unexpected operation of protection devices are involved.
Right.
Sometimes it's not possible to know, maybe human error in the setting. With hardware in the loop, we can take into account the interaction between the power system and the real protection device.
Great.
So we have a fault, then the protection device is going to open a circuit. Normally, in traditional test facilities, this is applied. We have a fault, and the relay opens a part of the circuit, and okay, the relay operates.
Yes.
But then what happens? Actually, the relay changed the circuit of the circuit is changed. If you open a part of the circuit, the circuit changed. So with hardware in the loop, we can take into account this interaction, because if the circuit changes, this is going to affect other protection device, right?
Right.
So there is an interaction, because it's not just an open loop test, it's a closed loop test. So the relay interacts with the power system, and also the relay interacts with other relays, right? It's a holistic approach. We can test also the communications. So if we have a protection system that involves many protection device relays, we can test the whole system together.
Great.
Yeah, we can apply different scenarios, because we are able to generate these scenarios by simulation that is digital and is very flexible. And then we can apply different scenarios and check if the system as total is working okay. And also, if what happens if one relay opens, what happens with the others if of the other relays are working as expected.
Thank you, Renzo, for this insightful introduction. So, could you walk us through a real example where hardware-in-the-loop testing supported the anticipation of a critical vulnerability in a component that, if gone unnoticed, could have caused a massive outage or a massive issue into the network in which the equipment was installed?
Yes, I participated in a project related to a TSO that involved 4 protection devices, and also in the context of photovoltaic generation, of course interfaced by a converter. The typical studies show that the protection settings were okay, but testing with our real-time simulation system and also in interaction with the other protection devices, it was shown that settings were not the best for this situation. At the end, the protection engineers updated the settings, and the whole system worked okay.
Yeah. And this is a fantastic closing the loop with respect to project, with respect to engineering, with respect to project done in paper with simulations in which you put the best of your knowledge in that moment, but then you close the loop with the reality, with such a lab, with such expertise and equipment, because then you test what theory is telling you in reality and you fine-tune. So that's a perfect example. Thank you, Renzo.
And also here in this medium voltage lab, we can conduct power hardware in the loop test that is it's an advanced technique in which we have a simulated part in our real-time simulator, and then we have amplifiers, and then we can test real converters. So this allows not only to test controllers or protection systems, but also real converters exchanging real power, and then we can test it in a very flexible and dynamic environment.
Yeah. Thank you very much, Renzo. So as power systems becomes much more distributed and complex, how do you see the role of hardware in the loop testing in the validation of not only the single equipment, but also of their behavior in a larger environment, in the biggest picture in which they then get installed? How do you see this in the future as importance?
I think hardware in the loop is a technique nowadays is very useful and very important. You know, now we have the new standard related to hardware in the loop tests, and I think it's important. Then you can edit this, of course. No, I think it's important because we can test in a more realistic way. We can test real devices, real protection devices, real HVDC controller, real converters controllers in general, and also we can test real converters. We work in grid-connected controller and chargers, electric chargers in general. So imagine now we have lots of lines of code inside a device.
Yes.
Nowadays, imagine 20 years ago we had electronic devices. Now we have digital devices. Everything is a small computer. So we have lots of lines of codes inside every device along the electrical system. Yeah. So debugging that is not that easy. It's not because traditional tests were thought, imagine testing a device, but nowadays this kind of protection devices or controllers or converters are very complex systems. So for testing that, we need a new approach that is that can include a holistic way to test the device itself and also to test the device in a system.
Yeah, so it is more of moving from the traditional approach of testing the single equipment in its specific performances and its specific boundaries to testing the equipment in a sort of interoperability approach with other equipment, with other disturbances coming from the ground, coming from the network. So other signals that can impact the equipment. So is maybe more moving and shifting towards that kind of paradigm, maybe.
Yes. Now we have. It's not a problem nowadays to simulate digital the behavior of electrical system. We can do that in real time, and then we can also interact with real devices, right? And interacting with those devices, we can find more issues that are not visible with traditional tests. And also, yes, as you said, if we have a project, for example, for including that includes some converters, protection systems, then we can test all together. We can test the converters with power hardware in the loop technique. We can test the protection system, including the communications between them and the total interaction in this complex electrical system. We can do that nowadays. And if we can do that, then we have to do, because these techniques allow us to de-risk misoperations and this kind of problems.
Well said. Thank you very much. Thank you very much, Renzo, for this insightful conversation and introduction to the world of hardware in the loop testing. I want to thank everyone that listened to our podcast today, and I want to renew the invite to check out our podcast list on our website and check out the previous episodes. There are a lot of interesting topics that we covered, from protection system, 61850 protocol testing, SF6 free alternatives. There is a lot to check and to learn from our podcast. So go in our website and check that out. And stay tuned for the next episodes that will be released soon with the other very great, interesting topics and guests in our podcast. Thank you very much. And thank you again, Renzo.
Thank you, Antonio. Thank you, Antonio.